Right. So today we're going to talk about descriptive statistics. Right. Okay, let's see what is descriptive statistics and how to do this with the software. So in this class, we're going to use the SPSS software. Right. Data, that's what you get. From data, we extract information. So from here to here, this part is called descriptive. Later, you move higher and higher. It's called data-driven decision making. The decision is going to come from the knowledge we have, which came from the retest done, or the hypothesis testing all done, from the information gained from data. So where do you start? Data. So this must be done as properly as possible. If this goes wrong, that will be wrong. So garbage in, garbage out. So pay attention how do you collect the input for your research. So now we're going to move from data to information. So that's called descriptive statistics. This is my population. So always I draw a box for population. I draw a sample. Normally I denote as a circle. Right? It's not the must, but easier to see. This is my population. This is my sample. So inside the population, say I want to study a variable. What's a variable? What's the definition of variable? What's the definition of variable? Changing? Changing. What's the definition of variable? Changing?
Yes, I'm here.
So what's the definition of variable? What is variable?
Valuable.
What is a variable? What is variable? Anyone can help her? What is variable? This term variable, what's the definition?
A characteristic of interest which take different value in different item or object.
Right.
It's like
Correct. That's why we went through last week. Variable is a characteristic of interest that takes different values and different items object. Let's call this X. So X can be weight. Is weight a variable? Is weight a variable?
No.
No. In the
Yes, it
population.
is.
The
Yes,
population.
it is.
Why do you say it's a variable? Why do you
Because
say
it's a value.
it's a value.
can be in different value.
It
Can be
different
different value in different items.
Weight differs from person to person. Differ, right? Again, what's the definition of variable?
Characteristic.
Who said definition of variable?
Take different value in different item or object.
Right. Takes different value in different items or object. Let's say two people here, husband and wife. Will they weigh the same? Husband and wife, will they weigh the same? School children.
No.
School children.
Unlikely.
School children. Do they same weight?
No.
No. What's opposite of variable? Opposite of variable is constant. School
Yes.
children. How many heads do they have? School children. How many heads do they have?
1 head per person.
1 head per person. Is that a variable? Does number of heads vary from person to person? Anis, does
Same.
number of head vary?
No, it's a constant.
Constant. But the weight? Does it vary?
That's a variable.
Variable. Let's call a variable. Let's say newborn babies. I'm taking the weight. This is a newborn babies. My variable of interest is weight of the newborn babies. Why am I interested in the weight of newborn babies? Why am I interested in the weights of newborn babies?
It's important if it's healthy. If too light, probably something wrong.
Right. Whether baby is overweight or underweight, right?
Overweight, yes.
Yes. Let's say variable X. My variable X is starting salary of a graduate. Starting salary of a graduate. This is starting salary. Is it a variable? Starting salary of graduates. Is that a variable?
Yes.
Yes.
Right?
Different from one person to
right.
another.
Depends on what industry you're going, maybe different. Right, there are two types of variable, right? What are the two types?
Like gender.
There are two types of variable. What are the two types of variables?
Manipulated and responding.
No,
Independent and dependent.
no,
Variable and constant.
no. How can variable and constant be two types of variable?
Nominal and ordinal.
No, before that.
Quantitative and
Quantitative and qualitative.
Quantitative and qualitative. That's what it is.
Yeah.
Variable can be quantitative or qualitative. Weight, quantitative or qualitative? Weight,
Quantitative.
Quantitative.
quantitative. Hypertension, hypertension.
Qualitative.
Because hypertension, yes, no, right?
Yes, no, yep.
Yes,
Yeah.
no. So this is
yeah.
qualitative. This is quantitative. Now what I'm telling here is whatever variable you collect, they can be quantitative or qualitative. You're going to descriptive statistics. How do you describe? It depends on the variable, is it quantitative or qualitative? Normally what you do, select the sample, say sample size n, measure the values on the individual selected, example height, weight, BMI, describe the characteristics like mean, median, standard deviation, frequency, proportions. Again, in the statistical analysis, you must mention this. Read the articles, right? So that's a class today. Given in a population, they took a sample, they measured some variables. How to describe this? So variables can be quantitative or qualitative. Quantitative, the numerical, can find the mean, average. Qualitative cannot find the average, so frequency and proportions, right? Example marks, quantitative. What's the mean or average mark? We change to grades, A, B, C, D. Then can't find the mean. Then talk about what's the proportion of A, how many percent got A, B, C, and so on. So remember, descriptive first, find out whether quantitative, qualitative, and then use appropriate method. Normally, in your chapter 4, your thesis, the first table will be demographic characteristics of the respondents. They can be age, they can be weight, it can be gender. So some will be quantity and some quality. So this class we're going to see how do you describe this given a set of data. Right. First, we're going to do quantitative, then qualitative. So in quantitative data, we are talking about measures of central tendency, where's the data centered, measure of dispersion, how much spread the data is, how much differ from each other. Then talk about skewness, data symmetry, is it symmetrical or asymmetrical. Then you talk about find out any outliers or extreme values, and then whether the data is normally distributed. Right? 5-point summary. Later, I'm going to show you how to do the analysis. And finally, we're going to do an example and report the findings. 5-point summary. What's the mean? 1 to 8.67, plus or minus 15.89. Now, this is a mean. This is standard deviation. Again, one click, the whole thing will be there. What's a mean? What is standard deviation? Let me show the output. So that's a mean, that value, standard deviation, this is a value. So describe the systolic blood pressure. Click some button, this table will come out. Take the mean, 1 to 8, plus or minus standard deviation. This tells you where the data is located. This tells you how much data is dispersed, spread from the center. Then we talk about median, right? And so on. Just click button, we have the median with the skewness. Then we have the box plot, we look for something, and then test the normality, and we report it. So these are 5 points we're going to go through this particular analysis, right? So before that, briefly go through what these are, how to describe them, how to interpret them. So where is the data centered, measure central tendency? We mostly use mean and median. Arithmetic average. Example 10, 20, 30, add them up and divide by number. But it's very sensitive to outliers. Later we'll see an example. Median, arrange the data in an ascending or descending manner and take the central 50th percentile. So arrange as in ascending order. Take the center, 50th percentile. Right, supposing there are 100 data points, take the center, which means at least 50% more than that value. Interpret this data. Right, example. Numbers 1, 2, 3, 4, 5. So what's the mean? Add them up. Divide by 5. Why 5? There are 5 data points. So 15 over 5 is 3. So mean is 3. Sorry, that is mean is 3. Median. Arrange the data. Where center? This center, right? How do you arrange the data? This is center, right?
Yes.
Right.
Yes.
So in this case, what do you see? Mean and median are similar. So what does it mean? Perhaps data is symmetrical. The mean and median are similar. Perhaps data is symmetrical. After we see what symmetry means. Now, the same 1, 2, 3, 4, but the 5,000, 5 became 5,000. Now what's the mean? Add all the values, 5,010, divide by 5, 102. That's 102, theoretically somewhere here. What's the median? What's the median? Where's the center?
3.
3. Chop one this side, chop one this side. Next, chop this, chop this. Where are you? 3.
3.
Just now, mean and median are same. Now, mean is very much bigger compared to median.
Yeah.
So when the mean is far from median, then data is not symmetrical. How do you know? Just look at this formula. Right? Look at this formula. Mean, x bar is mean, m is median. If these two are equal, there's 3 formula. I'm just focusing on this formula. X bar is mean, m is median. These two are equal. Let's say this is 25, this also 25. So what's the value in the box?
0.
0. So 0, data is symmetrical.
Okay.
Let's say this is 30, 30. Sorry, this is, let's say 80, 80. This is 50. What's the value in the yellow box? this 80 and this 50. Is it positive?
Yes.
80 minus 50, is it positive?
Positive. Yes.
Positive, skewed to the right. When the mean is more than the median, data is skewed to the right. Now, let's say X bar is 20, 20. This is 50. 20 minus 50, positive or negative?
So
Negative.
negative.
Negative, data skewed to the left. But now, why is it important we compare the mean and median? So in this case, mean and median are similar. So perhaps data will be something like this, symmetrical. Symmetry means what? We cut here, will you get equal halves? If I cut here, will I get 2 equal halves?
Yes.
Yes. Here, where do I cut to get equal halves? Cut here? Cut where? You won't give you equal
No.
halves.
Yep.
I mean, no axis or symmetry. Here, there is axis or symmetry, right?
Mm.
That's why symmetry means.
Mm.
Again, but in the formula, you can see that, yeah?
How should explain if the result finding is positive skew?
Later, I'll come
Yeah.
back to this. I'll come back to
Okay.
this, okay? I just want to show you the formula, right?
Hmm.
Now, beside mean and median, what else there? S, right?
Yes. Standard
S is
deviation.
standard deviation. So these two alone is not enough. We need to know this as well. So now you go to dispersion. There are several measures of dispersion. Currently, just know what it is, right? One of the dispersion measure is standard deviation. Right. Let's see what is standard deviation. Same data point. How do you find standard deviation? Right at the bottom. So this is a step you go through. So mean is 3. Mean is 3. Deviation from mean, 1 minus 3 minus 2, 2 minus 3 minus 1, and so on. We add this, what's the answer? We add all this, what's the answer?
0.
0. Useless. You know what I do? Square it. 4, 1, 0, 1, and 4. And add it up. How much? How much?
10.
10. So 10 is called variation. Look at that. This is variation. Sum, squared, deviation from mean. So find the mean, deviation, square it, and sum it. So that is your variation. Variance is a variation divided by n minus 1. Again, refer to this, right? Divide by n minus 1 is like average variation. Now, this is important when you do ANOVA later. And then finally, standard deviation is square root of the variance. So you don't have to remember the formula, but this is how this is derived. So later when you do the analysis, no manual calculation. One click button, this value comes up. Standard deviation. Square this, that's a variance. Right? So understand what is standard deviation. It's a measure of spread or dispersion of the data. Mean, where's the data centered? Median, the 50th percentile. Right? So one more, we come to skewness. So what is skewness? Right? Data symmetry. So whatever I discussed earlier now, there is mean, there's median, and then divide by standard deviation. Okay, look at this part here. This alone is not enough. We need the standard deviation as well. So this is a approximate formula. This is an exact formula. We can't visualize on this, so I show this formula Y mean and median. Equal means what? Median more than mean means what? Data skew to the right, like income. Exponent less than median, skew to the left. But generally, we can't expect perfectly zero like that. We give some leeway, plus or minus 1. Generally, the skewness value within plus or minus 1, symmetry can be assumed. Some researchers take plus or minus 3. I'm very conservatively taking plus or minus 1. Are you okay?
Yeah.
Supposing the mean is 30, median is 30, standard deviation is 5. 30, 35. So what is skewness?
0.
0. That means here. Now let's say now 40, 40, 30, and 5.
Positive.
Positive. How much is that? 30, 20, 10, divided by 5.
6.
10 divided by 5.
2.
2.
2 times the 3.
3 over 2. 1.5, right? Okay, this 30, this 20. 30 minus 20.
10.
10 divided by 5. 10 divided by 5.
2.
2. 3 over 2.
1.5.
1.5. Is it more than or less than 1.5? 1.
More than 1.
More than 1, then it's like this.
But it's not like 3 times 10 divided by 2 like that.
This one I say this one 30 and 20, right? 30, 20. 30
So-
minus 20?
10.
10. Okay, 10 times 3?
30. I mean, 10.
30 divided by 5? Okay.
6.
Sorry, I made a mistake. Okay. Okay. This xy is 30 and 20. How much difference? 30, 20? 10. Okay. Standard deviation is 5. Oh, yeah. 10, 10 over 5?
2.
2. 2 times 3?
6.
Ah, it's correct.
Ah.
Okay. Right now. Same thing.
But
I thought your math was bad. Mine was bad. Okay. Okay. 30, 20, 100. 30, 20. Same like just now.
okay.
30, 20. I make it 90 now. Okay. 90 here. 30, 20. How much difference?
10.
10 times 3?
30.
30 over 90.
0.3.
Is it less than 1?
Yes.
Yes.
Then can visualize something like this.
Okay.
So this alone is not enough. We need this.
But Prof, one quick question here.
Yeah.
But times 3.
Y times 3.
Yeah.
That's a formula. Formula, don't question, okay?
Okay.
Right? Somebody develop, just use it, right?
Okay.
Right. So I say that this approximate formula, this exact formula. SPS uses this. This for us is visualization. So 30, 20, 10. We don't know whether number 1, number 2. We need this. 30, 20, right? 10. We need this S value. So when you do analysis now, all are incorporated, just tells you what the skewness value. Now you interpret. Look at the example. What is skewness value?
0.271.
Is it less than 1?
Yes.
Right.
So symmetry.
Therefore, data can be assumed. I don't say data is symmetry. Data is assumed symmetry.
Okay.
Symmetry only when it is 0, perfectly symmetrical, right?
Yes, yes, yes.
As long it's not 0, then it say we assume the data to be symmetrical. So this information, mean, plus or minus standard deviation, median 1 to 9. What does it mean? At least 50% of the participants BP is more than 1 to 9. That means arrange all the respondents. Take the center. The center point is 1 to 9.50. So to the right, 50%. To the left, 50%. Right? And then look at the skewness and interpret. So here, so what are the points here? What are the points you're looking into?
Mean, mediums,
Right.
standard deviations.
Mean, that's my mean. That's my median. That's my standard deviation. And that's my skewness. A lot of things there doesn't mean they're useless. They are for some reason. But I'm just picking this for my 5-point summary. Right? Again, I'll just click button. No calculation in this class. Right. Let's go to next. Cover this. Box plot. So what is the purpose of box plot?
Look for outlier.
Outlier. So what the box plot does is partitions the data into 4 quarters. From here to here, 1 quarter, 1 more quarter, 1 more quarter, and 1 more quarter. Supposing there are 1,000 cases. 1,000 cases. So 250 cases will be below here. 250 cases above that. This will be 250 plus 250. So inside the box, there is 50%. So this n, the age of this is called Q1, first quartile, right? Or 25th percentile. This is called second quartile or 50th percentile is actually median. So this point is called the upper quartile, quartile 3. The distance between these two is actually the box length, is called interquartile range. What percentage of cases inside here? Inside the box?
50.
50%. So interquartile range is actually the cut point for the central 50%. Later we'll see when you use this, right? When you use this. Besides that, so 50% is inside here. Besides the box plot can be used to detect outliers or extreme values based on these dimensions. So what outlier can still be part of this population, just on the outer skirts. This extreme value perhaps doesn't belong to the population. It can be typo, typing error. You go and correct it. It's not typo, then you must see whether to keep it or move it, drop it. Right?
Professor, can we, for example, when you do the research, we have data like that. Can we just take it out or we just treat it like error?
Right. Supposing the extreme value, example, blood pressure. Blood pressure for this particular person, blood pressure is 160, so 200. Is it outlier or extreme value?
Extreme?
200, yeah? So we ask the doctors, 200 possible or not? Yes, it's possible. That means outlier,
Okay.
not extreme value.
Okay.
Another person, 250.
Oh,
Possible or not? Doctor say, where I got 250? Cannot. Then can be mistake, go and check. Maybe
Okay.
instead of 150, you type 250. Possible?
okay.
Possible? So correct it. Birth weight, 12 kg, 12 kilogram. Is it possible? Birth weight and newborn baby,
No.
12 kg. Is it possible?
No.
No, not possible.
I think the world records about 12 kg. World record. I don't see many 12 kg. That's what you do, you remove it. Right? So whenever extreme value, you don't make a decision yourself, consult. Then you can drop it. Don't simply drop it, okay? All right, so that's the purpose of box plot. Next. normal distribution. So normal distribution, there are three characteristics here, three conditions. First condition must be symmetrical. Does this look symmetrical? Does this graph look symmetrical?
Yes.
We cut
Yes.
here, you get two equal halves, right?
Yeah.
To be symmetrical, what must you have? To be symmetrical, what must you have? The mean and median must be close, right?
Yes.
Right. So first mean and median close, symmetrical. Your this particular your screen, is it symmetrical? This left of screen, is it symmetrical?
Look like yes.
We cut somewhere here, we get two equal halves, right?
Yeah.
Is it normal?
Yes.
Is it bell shaped? Your screen, is it bell shaped?
Yes.
Your monitor screen, is it bell shaped?
No, it's not.
No. Even though symmetrical, it's not bell
Oh,
shaped,
okay.
then
Right,
it's
right.
not normal distribution. First condition must be symmetrical. Second must be bell shaped. You tie a bell here, it will go ding dong like that,
Mhm.
right? It's a bell shaped. Third one, we partition the graph, the center, the mu is mean, sigma standard deviation. So mu plus 1 standard deviation, mu minus 1 standard deviation. This area under the curve must be roughly 68%. After giving an example. Now we move 1, 2 standard deviation to the right, 2 standard deviation to the left. The purple lines, this must contain roughly 95%. And the last one, 3 standard deviation, 3 standard deviations, almost 100%. So a distribution that fulfills the 3 conditions, then only we can say normal. It can be symmetrical, but not bell-shaped, out. It is symmetrical, bell-shaped, but does not follow the distribution, again it's out. Right? We can't be checking all this in your data. So we have some statistics to tell you. One value in the table will tell you whether you can assume normal or not. Example. Here the distribution is mean is 50, standard deviation is 5. The marks in exam. So what does it mean? From 50 plus 5, from 50 minus 5, 45 to 55. 68% of students' marks must be in this range. Supposing you take 100 students sit for the exam, roughly 68% of the students' marks will be between 45 to 55. If it's normal, this design means normal. The snake here is called normal distribution. Next, plus or minus 2 standard deviations, roughly 95%. Plus or minus 3 standard deviations, almost 100%. Right? Now, what are the chances of a value being 60? Is it possible? Is it possible a student gets 60 marks? Is it inside? This 60, is it inside the curve?
Yes.
Yes. What are chances of student getting 80%?
Super low.
Where's 80? Somewhere here, right? Somewhere here, right? 80?
Yes.
Almost. I'm not telling nil, almost nil. What are chances of a student failing?
Very high if 50 mark is the passing mark.
No, I didn't tell you. You must ask me first.
What is the passing mark, then?
Passing mark is 50, 50.
Oh, very
What are
high.
chances of student failing?
Almost 50%.
50%. The passing marks 20.
Everyone pass.
Everyone pass. To get A, must get 80.
Impossible.
80 is here, almost 9.
Yeah.
Right. Now, this is a very, very important curve, normal distribution.
Mm.
From shoe manufacturer, right, to medical researchers, agriculturists, right, those going outer space, all have used this normal distribution. Okay. Okay, standard normal curve. So what does it do? It just standardize them. Take the 50 minus 50. How much?
0.
0. Divide by 5.
0.
0.
That's 0. Take next one. 55 minus 50.
5.
5 divided by 5.
1.
1.
1. Next. 60 minus 50.
10.
Divided by 5.
2.
2.
2. And the last one. 65 minus 50.
15.
Minus 5. Divide by 5.
3.
3. So a standard normal distribution, nothing. It transforms the center 0. Center 0. So this is a table we use in most of the analysis. Plus or minus 1 means what? 1 standard deviation to the right and left. Plus or minus 2 means what? 2 standard deviation right and left. And 3 standard deviation. This is how the table is produced. Right? So don't have to know in detail. You must know what roughly you're talking about here. This is Z equals to 1. Z equals to 1, this area, the shaded area, this is 1. So Z equals to 1, what's the area under the curve? How much is this? Roughly?
0.15.
16. 0.16, okay?
Okay.
0.16. So this area is 0.16, right? Correct?
Yes.
This 0.16,
Yes.
how much is this?
50. I mean 0.5 minus 0.16.
34.
0.34
34.
times 2.
0.68.
This side got 0.68. Based on this curve, people done all the transformations and given you this particular table. So those days, without all the statistical packages, we use this table to make inference. We use these tables. Nowadays, nobody knows this table exists because like SPSS click button automatically gives you the p-value. So what's actually p-value? P-value is the area under the curve, right? The next chapter, we talk about what is p-value, next lesson. All right, so just now talk about transformation. This is how it's done. Take the x minus mu, all are standardized. 50 become 1, 0, 1, and so on. You don't have to know more detail of this. You must understand what the tail area means. What this tail area means. Take the Z, right? That's the area. So this we'll do later, more detail. Right, all this I skip, interest just read up. Right, example 1. That data set, I want to describe systolic blood pressure. So this is my data set. So for my data set, you just watch for that, don't do yet. Right? Okay, that's my data. We take the SPSS. Okay, this is my data. Let's see now, variable. Is SBP a variable? I go to the top. Okay. Is age a variable? Class
Yes.
age variable?
Yes.
Yes.
Gender?
Yes.
Yes.
Gender what? All are variables, right?
Yes.
Quantity or quality?
Quanti. Quali.
Quali.
Quanti.
Quantity, yeah.
Quantity.
This quantity.
Oh no, it's a range. So this is qualitative.
Can you find the mean of between these two? Less than 5 years, more than 10 years, can you find the average?
No.
Cannot. Whichever cannot average, they are qualitative. Can you find average?
Yeah.
Yes.
Here can?
No.
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 No. No. No.
No.
No.
Right.
No.
So that's how you recognize whether it's quantitative or qualitative. Right. Are they all qualitative?
Yes.
What about this?
No.
Quanti or quali?
Quanti.
Quantity.
Quanti. All this?
Quanti.
Quanti. All this?
Quality.
Quali.
Right. So data can be quanti or quali. So quanti, how to describe it. Quali, how to describe it. That's what I'm going to do. Right. So that's my data. Look at your PowerPoint slides. So what do? You just follow exactly what's inside the yellow box. Step by step, you follow this. Okay. Who shall I call? I don't have many names here. Jeffrey,
Yes.
can you read? Can you tell me what to do? Okay. You tell me what to do. Okay. Step by step, you tell me what to do. I'll follow. Okay. Go.
From the menu, choose analysis.
Okay. This is my menu. Analysis or analyze?
Analyze, sorry.
Analyze. Okay. Click that. Next.
Descriptive statistics.
That's descriptive statistics.
Explore.
Explore. And then what do you do? Just click. Okay. So this particular pop-out comes out. Is this same as this? Is this similar to this? These two?
Yes.
Right. Then what do you do? What's inside here? SBP. Because on describe SBP, systolic blood pressure. That's one. Click inside. Right? So it is there. Next, what do you do?
Plot.
Plot. Click the plots. And check what boxes now. What is not checked here?
The numerative plot with test and
Normality.
Is correct.
yeah.
This testing whether data is normal or not. Just I say must be symmetrical, must be bell shape, must be plus or minus, all that, or how to calculate all that. You tell me straight away whether normal or not. One click button. Right? Jeffrey, one more time.
Okay, click. Analyze, then
Nice.
statistics, and then explore.
Explore. Okay, explore.
Okay,
Choose the variable.
okay.
Choose the variable.
Variable.
SPP.
Click.
Plots.
Make sure you click according to the diagrams. Normally, plot
Right?
histograms.
Only these two.
Yeah, just now was that. Yeah, now it's click.
Right. Anis,
Yes.
so far how many clicks?
So far there's analyze, descriptive analysis, descriptive statistic, explore, list, and plot 5 clicks so far.
Are you sure? Okay, now whatever clicks, okay?
Yeah.
And then just click OK. Those days, how long would have taken to do this? Click button. Right, the whole thing comes out. So what are we interested in? This table we went through just now, right?
Yes.
Isn't it? We wanted what's the mean? What is standard deviation? So right, 128.67 plus or minus 15.89. And median, that's a median. What does it mean? Test your skewness. What does it mean? And then test the normality. Okay, look at your notes. Okay, this is a test of normality. There are two tests here. Look at this table here. There are two tests, Komogrov Simido or Superbelts. So which test you use depends on sample size. The DF is a sample size. The DF here is a sample size. Here is 108. If the DF is more than 50, we call large sample, use KS. In this case, what is the sample size? 108, right?
Yeah.
Is it more than 50?
Yes.
Yes.
Then use KS. Right, choose this. Next column, SIG, actually is called the p-value. SIG actually is called the p-value. So later, don't say SIG, you just say p-value.
Okay.
Now this p-value here, is it more than or less than 0.05? Is it more than or less than 0.05?
More.
More than
More.
0.05. Therefore, the three conditions are more or less met. You can say data can be assumed to be distributed normal. Don't say data is normal. Don't say data is normal. Right? Data can be assumed to be distributed normal because it's not perfectly normal. No data is going to be perfectly normal. Are we clear? Class, are you clear? Any questions? All right. So we're done 4 points. The table come out. Just look at the value. Which one? Look at the DF first. More than 50, we take this. Less than 50, we take this. And interpret the values more than 0.05. So data can be assumed to be normal. So now we have done this. We've done this. Skewness. We've done this. And we've done this. Okay, box plot. So what do you look for? So box plot automatically is there. Any circle above that is called a whisker. Whisker, okay? Any circle beyond the whiskers? Any circles?
No.
No.
Any asterisk signs?
No.
No.
No. So what does it mean?
No outliers.
No outliers or extreme values. So 5-point summary again. First table, you got this. Same table. Same table. This from box plot and this test of normality. So by looking at this now, we can more or less imagine how the data looks like. Right? Okay, second example, just look at the output. What's the mean? Mean is, so 2.7 plus or minus, we do the analysis, right? I do the analysis for this. Explore, remove BP, and put TG is triglyceride. Triglyceride. Right. Plots. Then this. Okay. You can follow the notes. Let's describe this. What's the mean?
2.7808.
Right. What is standard deviation?
1.75.
Right. So we say the mean is 2.78 plus minus 1.75. We say this. Next, what's the median?
It is
2.19.
2.19.
190. So what does it mean? At least 50% of the participants TG is more than 2.19. Next, skewness. So what is the skewness value?
Bigger than 1.
Is it more than 1?
1.9.
Therefore, data
Yeah.
is not symmetrical, right?
Yeah.
Data is not symmetrical. Now look at the test of normality. Homograph similar or Sapir-Whorf? Number 1 or number 2?
Number 1,
Number 1, because 108
more than 50.
more than 50. Now, when SPS reports like this, you don't say 0. You say less than 0.001. Right? We report as less than 0. When SPS reports 0.00, it's a truncated. It doesn't mean 0. There could
I
be
see.
some numbers and something. So you report less than 0.001. Don't say 0. Is it less than 0.05?
Yes.
Yes, of course, right? So don't have to say is 0.001 less than zip. No need. It's understood less than 0.05. Therefore, data is not distributed normal. Look at the histogram. Can you see a skew? Skew
Yes.
to the right, isn't it?
Yes.
Yeah.
Yes.
So it's
Okay,
positive.
5-point summary.
Mm.
Mean plus or minus that. The median. What does it mean? Skewness. What does it mean? The box plot. Okay, look at the box plot. There are some asterisk signs, right? These numbers are case numbers. Example, case number 34 means in your data, case number 34. Okay, this case number, right? That case number, let me run this and see where to find the value exactly. So just now I did the analysis. All right. See the box plot, 34, 70, 105. These values are roughly how much? 9, right?
Yep.
We put it this particular axis about 9. These are outliers about 7, right? We project this about 6.5 to 7.5, right?
Yeah.
All right. Let's see now. Case number 34. Case number 34. Look at the TG value for case number 34. Okay. TG. Right. 9, isn't it? Correct?
Yes.
Other value smaller. So that's why here it captures this 34 is too far from the others. So this group of variables, the values are very high. Shall I drop that? Shall I drop all this? Shall I drop all this? We don't know.
Should be.
Go and check
Don't know.
first. Maybe it's a
Okay.
typo.
Uh-huh.
1.00, you type 9.00. Possible?
Yes.
Very corrected.
Yeah. check.
Otherwise, consult whether it's possible or not. If possible, you have to keep it and do some form of transformation. Right now, the exercise is just to describe only. We're not making any inference. Right? Okay, let's go back to notes again. I show you one more. Let's say I want to do stress. I want to know whether stress, the 5-point summary. Right. So I'll do this. Take out this. So stress. Stress measured from 0 to 100. So individual people stress level. So this already checked it already. Continue and click OK. 5-point summary. You tell me what a 5-point summary is. Okay. Mean. Tell me what's the mean value.
48.74.
48.74 plus minus.
Standard. 16.97.
16.94.
97.
97. 60.97. 97. 94, right?
Okay, not
964. So it's 96. 96.
96. Okay. Median. What's a median? 49.
49.
mean.
Right. Keep the values percent. Skewness.
0.36.
0.36.
36. 0.362. Okay. Now, which p-value are you taking?
0.2.
Is it more than 0.05?
Yes.
Yes. Normality p-value is more than or equals to 0.200, which is more than 0.05. Box plot. Any outliers, extreme values?
No.
No. So So 49, what does it mean? At least 50% of participants stress level is more than equals to 49. Skewness is value which is within plus or minus 1, within 1. Therefore, data can be assumed
No.
symmetrical.
Be normal.
Box plot, no extreme
No.
and no outliers. Okay, no extreme and no outliers. Right. Normality, p-value more than 0.05. So data can be distributed normal, can be assumed distributed normal. So 5-point summary. So doesn't matter what data set comes in, just do this, you understand better, or centered here as a median. The mean and median, are they close?
Very close.
Very close. That's why skewness is very small. So we know 50% are more than this, right?
Yeah.
If the stress level more than 50, that's considered serious. What does it mean? The stress level is more than 50, you must do something. So what does it mean in this case? At least 50% are more than this, right?
Mm-hmm.
At least 50% are stressed, isn't it?
Yeah.
Then something must be done because 49 is not far from 50. You must do something if the stress level is more than 90. Now, what's your decision? More than 90. That's my cut point. More than 90, that's some problem here. Is it more than 90?
No.
No. I think it's still okay. If the cut point more than 40 is serious, what does it mean?
It's okay.
It's okay.
Everyone is very, very stressed.
Everyone's stressed.
Oh, yeah.
This
Yeah.
cut point must come from somewhere, right?
Yeah.
So we just describe only for this particular exercise. All right. Okay, open your SPSS. Open the file. Open this file.
How do I open the file?
Have you installed SPSS?
I already did, but it's on cloud. So how do I actually open the file in the cloud application?
Your file,
Yeah.
or no, your SPSS, have you installed in a desktop?
But how you put your file to the software?
Yeah,
Okay.
because I'm accessing it from cloud, so
Okay,
I
from
don't
cloud,
have.
can you download into your desktop?
No,
You can put in desktop.
we basically open it remotely right now.
Now the data I sent you,
Yes.
the data set 1,
Mm-hmm.
can you put in your desktop?
Yes, it's on my desktop right now.
Desktop. So now I go to file,
File,
open,
open,
data,
data.
right? So go to the location where you save your file. So mine is, what is files? All right. Mine is inside the data folder. That's my data. Click open. Right. You see this?
Hang on, I think I need to do it this way.
Now, anyone not getting this?
Professor,
Yeah.
how can we download this software?
Okay. Did the university send you the link?
Yes.
Yes.
but we cannot download it because there's we don't know the password, the username.
Okay.
Same as the school one.
School.
Yeah.
Now, anybody from China, it can't download? Any others can't download? Anyone can't download? Okay. Tan Xiaoji cannot download, right?
Yeah, I cannot download. I tried this in the morning.
Okay.
I tried the student ID, and my password is the passport number, but I cannot download it.
Cannot. Chengjing.
Yes.
Can you download?
Yeah, I can.
Okay. Can you help Tan Xiaoji later?
Okay.
All right. Anyone else can't download? Okay. So now you follow the instruction given the notes.
Prof.
Yeah.
How do I change the variable name? Because right now on my screen, it is designated 1 and 2. It's just
Okay.
numbers.
Do you see this particular icon, 1 and A?
Yes.
Click that.
Okay, got it. Thank you.
It's the name, the variable label and number.
Okay.
It doesn't matter. All right. Okay. So you follow your notes. Do exactly what is shown. Right. Do this. Repeat for BMI, SBP. Do for SBP. And see we're getting the correct answer. So you must remember this particular analysis. Later, for other analysis, we have to recall this. Certain analysis, we have to do this part, especially test of normality. All done?
Done.
Done, huh?
No. Prof, I'm not sure why my document is saved as Word and then I cannot open it in SPSS.
Which document?
The one which you sent.
The data.
Yeah, maybe I saved it wrongly.
Why save as Word file?
Yeah.
It just save the whole thing in desktop. Okay, don't change anything.
Okay.
How can yours? The SPS is open, right?
Yes, Prof. The SPSS is open.
Okay, let's see now. Try again. Now, whatever you're doing is a basic analysis, okay? So you can expect what more you are needed. What you need to do. Are you okay? Who was this now? Hello? Who was having difficulty getting the data? All okay?
Prof, I have the data, but I cannot open from the SPSS.
Okay.
Yeah, I cannot put the data set to my SPSS.
Yes.
Oh.
Same as you, right?
Same here.
Yeah, I trying
Like,
can't put it.
So you can't bring the data into SPSS, is it?
yeah.
Okay, this is my data set. Let's
Yes.
see whether you're doing correct. This is my data set.
Yes.
So I save this.
Mhm.
That's in desktop. So I save this file in desktop. Okay. I close this. Your SPSS, open SPSS.
Okay.
SP, yeah.
Right. So yours will be like this, right? Is yours like this, blank like this?
Yes.
Yes, huh? Okay, right bottom, the right bottom here, does it read IBM statistics is ready? The
Yes.
bottom part, yeah?
Yes.
Yes. I go to file, open, data.
Okay.
File, open, data. So my data is saved just now in desktop. Desktop. So I go and search the file, data set 1.
But our part here is only showing our file and then this PC libraries and network. It's totally different from my desktop.
Yes, mine too.
Yes, true. The same thing here.
What I did was actually I moved the file to a different hard drive rather than on desktop.
Okay. Such as where?
Like for example, mine, when I wanted to open up the file,
Hmm.
because we are right now using this on cloud, right?
Okay.
So it allows you to also access our desktop on cloud.
Okay.
So what you need to do is you need to open the data. Hang on, let me just retract back my movement. So I go to desktop this PC.
What? Desktop, go to desktop.
Yes, for me, it says here desktop this PC, and then it listed down all the hard drive that is available on my current computer. But for some reason, I cannot go to my current desktop on the list. So instead, I go to a different hard drive. That means in this case, D. I just put the file there and open it from there.
From anywhere else can, but not desktop, is it?
Yes, anywhere else, but not desktop.
Okay, let's say save in the. So it says desktop cannot. So what else?
So
can you go download? Go and download.
I'll try to read.
So now here, I save inside desktop. I'm going to save in my download. Download here.
Let's see now. Download.
Right, and save.
Oh, I can already.
Can?
Can?
How?
I put in this PC and then data D. They have a C and D. I set a folder in a D. I put to open it.
All right. I mean, desktop does not work, right?
Yes. For some reason, it won't detect. It just like open up the rudimentary folders for C, so it doesn't show your desktop.
Okay.
So best for you to put it on a different hard drive.
Hard drive, huh? But the download doesn't work, is it? We say download.
I think we can, but you have to find out how to open up download from the open data. I'm still trying to figure out. But
Now, once you put download, it's in the download. We go to SPSS. Can you open the download file? File, open data from the download.
Prof, the problem is we don't know where to find the download.
Yes.
You don't find download.
Because our site do not same thing like what you are showing there.
Oh, okay. All right.
Our site will be just only having the PC and then C or D, something like that.
Oh, C, just C, is there?
I'm using a D because I can see the D directly.
All right. So what it's telling is, okay, go to this file, save as. So save where? You go to change to, you put C, is it?
Maybe you can
Like this
Maybe-
PC, this PC there.
This PC.
maybe you
Okay.
can put it under. I'm trying to find out.
This PC
They
can
have the-
still go to download, right?
No, no, no.
Or you want to create a folder?
Go down. Yeah, they have a C and a D. I mean,
Okay, different. Okay, whether your D, right, wherever you want to put it, or you want a pen drive, right?
for my side, I'm not sure about. I need.
Or maybe what you can do also try to locate the file in your current C, but under the program files folder, put it somewhere there because
Okay,
I'm able to open data from that location.
all right. Even from my C, can I put
So
that
yeah, see, click program files,
program files? Okay,
put it inside this folder. Just save it
Okay.
here.
just save
Yeah, and then you should be able to open it from the SPSS.
somewhere, right? You can
Yes.
open.
Yep.
All right.
So I still don't understand.
Now,
So confusing.
you open from where? From the
From the
email?
Mac, from the Mac, from the Apple.
Oh, Apple, I'm not familiar.
Oh, you're Apple.
Yeah. Yes.
Apple, this is different. It should be okay, why?
Yeah.
How many anyone using Apple can open the data? Anybody using Apple can also can open the data?
I'm using Apple, but I'm still figuring out.
Apple.
Okay, it's okay. Maybe I'll go to YouTube and check
All right. Okay, good. YouTube is a good friend, right? Okay. Okay, rest. Just complete this exercise. Okay, just do this. Anybody try buying that from what my students suggested?
I downloaded the free version for 1 month first.
Oh, 1 month. Okay, it's a free version.
Trial version. Yep.
Yeah.
But the school already give us this ones. We can use it, right?
Yeah, should be able to use it.
Yes, I also downloaded the IBM for 30 days.
Okay.
And then I decided don't do it because it's $99 per month.
The IBM, the temporary license. You can use a temporary license, right?
Yes, for 30 days.
Only 30 days.
No,
but afterward,
30 days use it. Then make sure you get the system from Taylor's, okay?
Yeah, I don't want to move the data again, so I use the school one.
Okay. All right. Something that
you should really just download from the cracked version. It's free forever.
I didn't tell you, okay?
I download all my engineering software.
Okay.
The one I told you all in WhatsApp, even my IBM, there's no problem at all.
Okay.
It can be trusted. It can be.
But I cannot download for the Mac.
All contact on you, Juan, okay?
Yeah, that is
All right.
Yeah, because uni, they don't give for free. Even if they give, it's only student version and will expire. I mean, even in 1 year.
Correct. I mean, Malaysia is very common. People are using it. Okay. Okay, are you done? First one? Those you don't have, it's not working, just observe. Complete number 1?
Yes.
All right. You can see all that. Okay, do number 2. So that's your summary. Number 2 is TG, triglyceride. Laila? Laila, are you there? Laila? Laila, I haven't seen you last 3 days, 3 classes. Okay, are you done, number 2?
Oh, poor thing, I can't do it.
Okay, it's okay. Those can't download. Okay, hold on first. How many cannot download the SPSS? Can you wave or something like that?
SPSS is okay, so I'm just having trouble on the data at the moment.
You still can't open the data, then?
Yeah.
Yeah.
Me too.
Did you save the data in the C drive just now?
Yeah, I did what Anis suggested, but it's still not working. But that's okay, so I'll keep trying. I'll see if I can.
All right. Okay, now do one more and give me this 5-point summary for the data for the variable BMI. For the variable BMI. Do the 5-point summary for the variable BMI. Okay, what's the mean?
28.4.
28.4. And deviation?
5.24.
5.24. Median?
28.
28, which means?
More people have BMI less than 28.
Less than 28, or which one must emphasize? More than or less than 28? Which one must emphasize? BMI more than 28 means what? Obese, right?
Yes.
Then we must emphasize this. At least 50% of participants BMI more than 28. That means you're telling at least 50% are obese. Right? Of course, when you say either way, but better to emphasize the obesity aspect. All right, skewness?
Negative 0.127.
Negative 0.127. Is it within plus or minus 1? Is it within plus or minus 1?
Yes.
It can be positive, it can be negative, as long as within plus or minus 1. So data can be assumed symmetrical. Right. Box plot.
Prof, where are you typing right now? I can't
Eh?
see it.
No.
You can't see? Oh, I stopped sharing. All right. So that's a mean, median, right? Skewness. All right. Box plot. What do you see in box plot?
No extreme, no outliner.
No extreme, no outlier. Normality. What's the p-value?
0.002.
0.002. 002, right?
Yes,
Is it more than or less than 0.05?
less than.
Less than. Therefore, data is not distributed normal. Say it can be symmetrical, yet not normal. Possible. Okay, sometimes, especially sample size large, very difficult to get this particular condition. So currently, what we follow is this, based on skewness and kurtosis, right? According to this, okay? So he suggests you take the ratio between the two, which means from the analysis, he suggests right. So that is statistics. So that is a skewness.
Prof, I'm sorry,
Can you
Prof,
not
but
see anything?
the screen is kind of like stuck right now.
You can't
Yeah,
see?
cannot see.
Yeah, we can't see anything.
Oh, now it's
Okay.
okay.
It's
I
back.
can see.
Oh no, you
Okay.
stop sharing. Is it for me? Oh my God, my Zoom
Okay.
is bad.
Yeah, now can.
Now okay.
Okay. So look at the equation here, Z1.
right.
So what is Z1? Skewness over standard error. So that's your skewness, right? The standard error, okay, this is standard error. This column, that is standard error. And this row, that is skewness. Find the ratio between the two. Let's call it Z1. Find the ratio between the two. Let's call it Z2. Doesn't matter positive, negative. So now based on these two, how to make decision or assessment normality based on these two. So sample size less than 50, small sample. The Z1, Z2 must be more than 1.96. Right? Sorry, if data is more than 1.96, it's not normal. For less than 50 sample size, Z1 or Z2, either one more than 1.96, data is not normal. So both must be less than 1.96 to say can consider normal. From 50 to 300, you follow this cut rule. 3.29, 3.29. Anything more than that is not normal. Okay, less than that, can assume normal. More than 300, usually for master's PhD, that's what you have for social sciences. He suggests check few things. Check the histogram and box plot. Right? Box plot, we can see any outliers and everything. If there are no outliers, there are outliers, data is not normal. Sample size more than 300, there are major outliers or extreme values, then data is not normal. If no extreme values, check the skewness and kurtosis just by itself. Don't have to go to Z1, Z2. Check the skewness values. If the skewness value is more than 2, or kurtosis is more than 7, data is not normal. If less than 7 and 2, you can say data is fairly normal. So nowadays, very difficult to say based on the p-value, most of the time is less than. We are using this particular author's proposal that with a large sample size, we can make a decision based on this, provided there are no outliers. Are we clear?
Okay.
Class, are you clear? So just now, if I were to do for which variable? Just now I did for BMI. What's wrong with this? Okay, BMI. Okay, is the data normal? Is the data normal? Class, for BMI. The p-value, is it more than or less than 0.05?
Less than.
Less than, therefore data is not normal, right?
Yeah.
Okay, let's look at the box plot. Any outliers, extreme values?
No.
No. What sample size?
108.
108. Now, is it this one here?
No.
No. Is it this one here?
Yes.
Yes.
Yes. Okay, let's calculate Z1 and Z2. So what's Z1, what is Z2 for this example? What is Z1 and what is Z2?
Negative.
Z1 is 1.2, take the positive, the sign, forget about the negative. 1.27 divided by this. Is it less than 3? Is it less than 3.29?
Yes.
Yes. This 9446. Is it less than 3.29?
Yes.
Yes. So even though the p-value is less than 0.05, the box plot, no major outliers, extreme values. And these two values are less than 3.29. According to this author, you can still say data is fairly normal. Don't say data is normal. Data is fairly normal. So these are other means of showing. So don't rely so much on the p-value. Okay? Questions? Okay, no questions. We're going to describing qualitative variables. Right. Okay, qualitative variables. So we know we can't find the average. So we're going to use this procedure, frequency procedure. What comes out? Table. We have frequency and percentage. That's all. Very simple. Not as messy as the quantitative variables. Right. Let me show you this. Are you all ready? Class, are you all ready?
Yes.
Yes.
Right. So you're going to follow this particular procedure. Analyze descriptive frequencies. Variable name. What variable? Job category. That's all, nothing else. Just bring this and click OK. Anis, how many clicks? Anis, how many clicks?
4.
Okay, simple one.
Analyze descriptive frequency. Okay.
Okay, right. So look at the output. Very simple. So what do you say? Attended nurses, doctors. The sample 33. 60.66% were attendance. Nurses 36, 33.3. Doctors 39, 36.1. Just describing this. Now, note this. Why these two columns are same? These values, the two columns here, percent and valid percent, are the same?
Yes, because
Why
yes.
we need two like that?
Because the 100% can classify for the three job. No
But why
abnormal.
must you have two? Exactly same, right? These two exactly
Because-
same, isn't it? Any difference between percent and valid percent?
Yeah, because sometimes it happens that more than 100 maybe, or less than 100.
Now, my
If
question
the-
is these two exactly same? Why two columns? These are same, right?
Yes.
These two values are same values, right?
Yes.
Why repeat? Okay, look at the next one. Marital status. In marital status, single 27, married 63, once married 12. What about the 6 year? Missing. That means these people did not mention the marital status.
Right.
So in SPA, look at here now. They did not reveal the marital status for some reason. So we count all this. If I ascend this, so you can see that 6 people did not disclose their marital status. So these 6. So these 6 are the missing. So this percent, it considers 108. So 6 over 108, 5.6% missing. But we must report this of the known values. Look at the difference now, 25, 26, right? They are different. So valid percent takes a 102 as a denominator of the known cases. Percent takes a 108. That's why when you look at these two, especially when there are missing values, we report the valid percent. Are we clear? Class?
Yep.
All right. Okay, final, we can do the exercise. I want you to prepare this kind of table. So in your chapter 4, first table will be demographic characteristics. Don't put one table for gender, one table for age. Okay, open Word file. I'm going to show you how to do this. Later assignments, I want this to be what I showed today, right? Don't simply put all the table, one table like that. That's not mine. Okay, so open a Word file. Okay, table 1. Demographic characteristics of the respondents. So insert table, some rows and some columns. This is a variable. Frequency and percentage. Plus or minus standard deviation. let's see which variable I'm going to describe. All right. Okay, demographic. What are the demographics? Age, gender, all these demographics. Let's start. Analyze descriptive frequency for qualitative variables. Now I'm not going to do one by one. I can do all whatever together. Gender, category, years in service, marital. Let's say these are demographics. Bring it in. And click OK. The first variable. Gender. Okay, male. Okay, frequency. Female, male 51. 47.2%. 57. 2.8%. Right. It's not necessarily do one by one. All can be done simultaneously. Job category. Okay, attendant, nurse, and doctor. So fill up the table.
Prof, sorry, just to confirm. So here the percentage we are reporting the valid percentage itself only, right?
Valid, but here there's no missing means they are same, okay? When
Okay.
it comes to this marital status, you report the valid percent.
Okay.
Here all the same. For example, marital. Okay, we are single. Okay, this will be 27. Hello? Yeah. Okay, just fill out the table. So before this, have a 108 respondents in the study. The demographic characteristics of the respondents are shown in that table. Later assignment, you must show me this table first, okay? The demographic characteristics of the respondents are shown in table, let's say table 1. The chapter means 4.1, right? So I can put table 1. So now you describe this, don't write one by one. Okay, about gender. In terms of gender, the distribution. Are they similar? Can I say almost similar? Can I say similar distribution?
Yes, almost 50% each.
More similar. Right. Job category? In terms of gender, and are they similar also? And job category, are they similar? Look at job category.
Yes.
Similar, right?
Yep.
Were similar. Distributions were similar. Okay, now let's talk about years of service. Right. Majority, are they like 5 to 10 years service?
Yes.
Right. Majority. How many percent? 41.7% of the respondents. How many years of service?
5 to 10.
5 to 10 years service. 5 to 10 years. Marital status? 58%, right? Married, right?
Yes. Yes.
8%. Highlight what is glaring, what is so different. That's all. Don't put one table for gender and a chart for that. No. Students are very much interested in charts. My chart. You copy and paste one chart for every variable. At this level, you don't expect this. What is that I can't see from the table? You must show me in the chart. Right? So that's the starting point of chapter 4, demographic characteristics. Mention this and produces done. Age. Okay, let's come to age. Age quantitative or qualitative? Age is
quantitative.
In this example, right?
Yes.
Here is quantitative, right? Age. Any other demography which is quantitative? Okay, let's say I use weight and height, right? These two also. Weight and height. I still do all three in one go. Right? If you want normality is fine. Click OK. All right. First check whether these variables are symmetrical. Age. Is this symmetrical? Look at my screen. Is A symmetrical?
Yes.
Yes, okay. Weight?
Yes.
Weight, symmetrical?
Yes.
Yes. This one, the height? Height?
Yes.
Okay. I just going to add one more variable just to show the difference, okay? We know that TG was not symmetrical. Just an example, okay? All right. Okay. Triglyceride TG. Is it symmetrical?
No.
Okay.
No.
So triglyceride, let me change to income, okay? There is demography, right? TGA, let's say for income in whatever units. All right. The variables are age, income, height. I just put weight, right? Just weight. Okay. So they are mean and standard deviations. Let's go to age. What's the mean age? Mean age 41.56 plus minus. What is standard deviation for age? Standard deviation is 5.41. Two decimals enough. Income. Is income symmetrical?
No.
No.
Then don't use mean. It's not symmetrical. Don't use mean. Right? Use median. Right. Report median. That's a median. And interquartile range. Median and interquartile range. So 2.19 bracket 1.66. Put asterisk sign, footnote, say median. This is short form for interquartile range. Just to differentiate, it's not mean.
Okay.
All right, that's understood. So when I see like this, I know why you should suddenly use median. This means using median. That means perhaps income is not symmetrically distributed. Right? Weight, symmetrical, okay. Weight will be 77.38 plus minus. What is standard deviation weight? 15.20. All right. Okay, that's all. So table 1. So what figure go to table 1? Demo characteristics. Just explain the major, whatever differences. So later I give an assignment. First must tell who are respondents in this study. After that, maybe you do regression, ANOVA, whatever it is that follows up. First, you must tell who are your respondents. Okay? Questions?
This is going to be our homework.
No, an example.
Oh, okay.
Right, how you present it. Okay, take a short break. I'll see you at 5:45.
Okay.
Okay, 5:45. We do the next lesson.